let's go for the constraint motion. So motion dependent on each other. Okay, so suppose that if you have a one pulley and pulley is attached here, and there is a one mass, sorry, there is a one string and there is another string. Suppose this point is a and this point is a B. Okay, suppose that this string will go x direction in up direction. Okay, so the what about the other? So this will also go x direction in down direction. Okay, downward direction. That is called the constraint motion. So here velocity, if you differentiate it, so velocity of A is equal to the velocity of B. Yeah, some important point here. If you suppose that A is like this and another is like this, then you have to think about in this, suppose this is the point A and this is the point B, okay, and suppose that this is moving in the horizontal direction, okay, with some theta angle is given here. Then you know this velocity is a VA. Along the direction of a string, this will be the VA. But what about the VB? So the VB equal to VA cos theta. So now a short trick for find the acceleration between the block. So you know work done, net work done by the massless string on the block will be 0. So you can write here T into x displacement, this will be the 0. Similarly, you can write T into velocity, this will be 0, and third you can write T into acceleration equal to 0. Now I am going in detail. This is very important, how to find the acceleration of the two. Like see the example. So suppose that here tension is a T, and if you have a same string, so always tension will be same because due to massless string and massless pulley. But here what about the tension in this string? So pulley is a massless, so suppose that here you have T1. So write the equation for the pulley. For pulley, so for pulley you write upward force is a 2T, downward force is a T1. So the 2T minus T1 equal to mass into acceleration. Mass of the pulley is given 0, so T1 equal to 2T. So always you have to write here 2T. If you a string is a massless, then tension in this the block B will be 2T. Now we have two, one is a block, another is a block. Find the relation between the acceleration of A and B. So how to find? So just write here, suppose that this is a going in A acceleration in downward direction. What is the acceleration of B? Okay, so what you have to do, this is very important, T into A equal to 0. Okay, and only you have to write for masses, because if you have mass then you have work done. Okay, so only go for the masses. So here you have A and here you have B. So to go for A, so tension is a T and is going with A acceleration in downward direction. So we have to write minus A, because in the sign convention downward is a negative and upward is a positive. Okay, so here you have to write T into minus A plus what about tension in B? There is a 2T. So you have to write 2T into, suppose that acceleration is a B, we don't know, we have to find out. So AB equal to 0. So here T and T cancel. So the AB equal to A by 2, and this is the positive. So it means A is if A will come in downward direction, so then B will go in upward direction with acceleration A by 2. So this equation T into A equal to 0, this will very important to find the relation between the acceleration of masses. Let's see. So okay, so find the relation of acceleration between mass A and mass B. Okay, so first step, you have to draw the tension in a string. This is the first step. Okay, so in this, suppose that tension is a T, same string you have, so tension will be exactly same. Now we have massless pulley, so tension here as you see before, this is a 2T, T plus T, 2T. Now here 2T, same string you have here, so this string will also 2T, 2T you can write here 4T. You have now same string, so this will be the 4T. Okay, so now find the relation between acceleration of A and acceleration of B. So anything you have to just suppose that acceleration of B is a in upward direction. So what about acceleration of A particle? Okay, so go for T into A equal to 0, where you have masses. So here you have now mass. So mass B, what is your tension on mass B? 4T. So you have to write 4T. into what is acceleration? A. We have already supposed that A is going in upward direction, plus tension on M1 like mass A, that will be the T. We don't know about the acceleration of A, so we just write AA that equal to 0. So tension will cancel. So now acceleration of A, this equal to minus 4A. So minus is showing direction of acceleration of a particle in downward direction, and magnitude is a 4A. So this will T into A only will give the information about relation between the relation of acceleration between the two masses. That is very important. And how to find the net, that you am going to. So how to find the A. So suppose that if you have here again I am repeating massless spring and mass is m is given. So the mg will act in downward direction at A point, B point, C point. Every point tension will be same. So TA, TB, this equal to TC, that equal to mg. Okay. Here you have one rod, length given L and mass given m. What is a tension? So tension at each point is a, you have to find how much force acting below that point. Okay. So tension at A equal to 0 because there is no mass behind this. Okay. What is the tension at point B? So tension at any arbitrary point, first you have to take one element from the x distance from the bottom, there is a element dx. Okay. I know the tension is only ma m into g. Okay. So the tension at any point, arbitrary point t, suppose that this is a dt. What is the mass of the dx element? So mass of the dx element is mass per unit length L. Suppose this is uniform distributed mass. So mass m by L multiplied by dx. This will be your mass multiplied by g. This will act at this point in downward direction. So just take integration. So the t at any point with respect to x, 0 to x. So the m by L x g. Okay. So this is the tension in the string. If you have a string has mass, so you can write tension as a function of x, this equal to mg by L into x. Now what at point A? At point A. At point A, x equal to 0. So tension at A equal to 0. At midpoint B, at B, x equal to L by 2. So the tension equal to mg by L into L by 2. So this will be mg by 2. What is a tension at C? So tension at C equal to, you have to write mg by L into x. X will be for L. For C, x will be L. So L cancel, that will be the mg. So the maximum tension you have at this point, that is a mg. Middle point is a mg by 2. Okay, and the general formula for tension at any point in the string, this will be mgx by L. So sometime people ask question, if you apply force, where a string will break, at A point or B point or C point. So where you have maximum tension? So maximum tension at C point, that is mg. So a string is going to break at C point. Let's find this question B. Suppose that there is a mass, capital mass m, and mass of the string is a small m given, and there is external force applied on the mass on the string F. So find the tension at point A. Okay. So what you have to do, because whole thing combined, a small m and capital M is moving in forward direction. So you have to find the combined acceleration. So the combined acceleration is a force by total mass m by a small m. Okay, this is the first step. Now draw the free body diagram for this small mass. Only half I am drawing. So here F is acting in this direction and tension will be act in here. So you have to find this is a TA. And what is a mass? Because it is half, so this will be m by 2. So you have to just write the Newton's second law. Net force equal to mass into acceleration. Where is this mass is going? In the right direction. So F will be greater than TA. So you have to write F minus TA, this equal to mass into acceleration. Acceleration is given F by m plus capital M. Okay. So you know that TA equal to F minus mf by 2 into m plus capital M. And this way you can calculate. Okay. Let's go for another question. Suppose that one mass is given 3 kg mass for 30 centimeter. So this length is given 30 centimeter. Okay, one side of the string is acting 20 Newton and other side is acting 32 Newton. Okay, so the question is find the force exerted by the 20 centimeter part of the rod on the 10 centimeter part of the rod. Okay, so first step is this 30 centimeter block is moving combined actually, including the 10 centimeter, 20 centimeter moving with the constant acceleration. Okay, so find that acceleration. So that acceleration is a net force divided by mass. Okay, so here is a 32 Newton, this side is a 20 Newton. So what is a net force? 32 minus 20 equal to total mass is given 3. So that is 12 by 3, 4 meter per second square. So this suppose that this is the A part and this is the B part. So A part is also moving 4 meter per second square, B is also moving with the 4 meter per second square. So find the force between the two. Okay, let's draw the free body diagram here. So suppose that this is the A. Okay, so what you have to find the force exerted by 20 centimeter part of the rod on the 10 centimeter part. Okay, so first you have to think about why A is moving, because A is not directly attached with the 32 Newton. B part is directly attached with the external force. So the A is moving because B is applying force on A. That is I am just writing here, that is a T. Okay, so T is acting in the right direction and here 20 Newton is acting in left direction. So how to write the free body diagram? How to write the Newton's second law equation? So net force T minus 20, because this is going with A acceleration in the forward direction. So T minus 20, this equal to mass. What is the mass of A? So the 30 centimeter mass. So what about the 10 centimeter? It will be 1 kg. Okay, so this is the 1 into A. A is given 4 meter per second square. So T equal to 24 Newton. Okay, if you go for the another like B, it will also give the same answer. So you have to draw the free body diagram for B. In this direction, force acting like a 32 Newton and A will apply on B in that direction, always equal and opposite. Okay, because this is the contact force. So suppose that this is the T. So here also you can write 32 minus T, this equal to mass. Mass will be 2 kg because this is a 2 kg, 20 centimeters. So 2 into acceleration is 4. So the T equal to 32 minus 8, that will be the 24 Newton. Okay, let's solve this question. Okay, so here is a very important. First you have to draw the free body diagram. So the M3G will act in downward direction. Tension is here T you have, and here will also act with same tension T. This is a M2G. Here T and T, then of course this will be the 2T, and this is a 2T, and this will be also 2T. So first we have to find out the relative acceleration between the M1, M2 and M3. Okay, so how to find the relative acceleration? So first step you have to apply T into acceleration equal to 0. Okay, so suppose that this one M1 is going with acceleration A in upward direction. So whole this part will move with A. But suppose that here there is a A1 acceleration, this is relative acceleration with respect to this pulley. Okay, either it going this way or you can apply T into A equal to 0. Okay, so you have to write the equation for all masses. Go for first M1 masses for M1. So for M1, what is the net force? 2T acting in the upward direction minus M1G, this equal to mass into acceleration. This is the first equation. Now go for M2. So M2, where is this is the, so where is M2 going? Directly you can assume suppose that A1 you have in downward direction. If answer will come positive, then your assumption is correct. If a answer is a negative, then you have to just reverse the direction of acceleration. Okay, so this will go in upward direction. So which force will be greater? T will be greater. So T minus M2G equal to net force with respect to ground, because this pulley was coming with acceleration A, but this is going with acceleration A1. So always you have to, what is the net acceleration? This will be A minus A1. Okay, that is a second. Third, you have to write for M3. So M3G going in downward direction, so M3G will be greater, so M3G minus T equal to mass into acceleration. So M3, what about the acceleration? So A1 is going, whole pulley is coming with A acceleration. So both here is going to add A plus A1. This is a 3. You have to solve and you can get the answer. Okay.